All right, so today we're into topic 2. We're going to spend the next couple days on that. You have a quiz on Friday over 1 and 2. Okay? So topic 2, reciprocal trig functions. This is where we deal with the other 3 functions, the 3 that we usually leave out. So you got sine, cosine, tangent. Hopefully you've read about the other functions on the top of page 608. You take a look at those. That gives you your cosecant, your secant, and your cotangent. Okay? So, if you haven't copied those down yet, you need to get those into your notes. Okay? Your cosecant is 1 over sine. Your secant is 1 over cosine, and your tangent, or your cotangent, is 1 over tangent. They're called your reciprocal trig functions because if you know cosecant, or excuse me, if you know sine and you take the reciprocal of it, you get cosecant. If you know cosine, you take the reciprocal of it, you get secant. If you know tangent, you take the reciprocal, you get cotangent. So for instance, if I said I had, if sine was equal to, or sine theta equaled root 2 over 2, then that would mean cosecant. By the way, where is that root 2 over 2?
45 degrees.
45 degrees. So theta in this case would be 45. Okay? So the sine of 45 is equal to root 2 over 2. The cosecant of 45. Okay? We would flip that. It would be equal to 2 over root 2. All right? And we can't leave a radical in the denominator, so right now I want everyone to rationalize that. Okay, so we multiply by root 2 over root 2, that special number 1. That gives us 2 root 2 over 2, which is root 2. Okay? Any questions on that? Okay. So really, when you see the 1 over, that just means the reciprocal. Okay? So don't let that part confuse you. That seems to be a hang-up, which means probably we haven't emphasized it enough throughout your math education. That just means the reciprocal. This is the reciprocal of that. Think of it anytime you see that as a reciprocal. And a lot of the old graphing, or in a lot of the other calculators, some of the scientific ones, you'll see that a lot. It just means you're flipping your fraction. Okay. Any questions there? I want you to take the sheet that you picked up on the way in. All right, that is the one, that big table looking one. This guy here. And I want you to, given the radian measure, 0 to 2 pi, I want you to go ahead and fill out what your sine is, the exact angle. I don't want decimal form. So exact. So for instance, if we did pi over 6. Sine of pi over 6 is? Uh-oh.
Root 3 over 2. Root 3 over 2. Root 3 over 2.
That's the degrees. Everyone get a unit circle out if you don't remember.
No.
I'm asking what the exact measure of pi over 6 is, of the sine of pi over 6.
1 over 2. Uno encima.
Okay, everyone take their calculator real quick because a lot of you aren't getting your unit circle out. You should find the unit circle. You'll need it to. Everyone do sine of pi over 6 on your graphing calculator.
Wait. No, it is root 3 over 2.
Okay, what do we have? Yeah, it's 1/2. Okay, what's cosine?
0.
Cosine of pi over 6 is? Root 3 over 2. Tangent. What does tangent mean?
Oh, it's sine over cosine.
Tangent is opposite over adjacent, right? So you've got to think of your unit circle again. Everyone take a look at a unit circle.
cosine over sine. Right. Opposite of the angle. Your cosine is y.
Real quick sketch of a unit circle. Really not a good sketch. All right, unit circle. Right triangle. This is what? This length. Cosine. This length. Sine. That was on your test. Okay? So cosine theta, sine theta, tangent. Tangent, we know, is equal to
Sine over cosine.
the opposite over the adjacent. The opposite over the adjacent is equal to? What's the opposite of theta? Sine. Adjacent. Okay? All right. Sine over cosine. So, when we're dealing with this, we have our root 3 over 2, 1/2. Tangent is equal to sine over cosine. Sine theta over cos theta. So in this case, that's 1/2 over root 3 over 2. And we're not going to write it like that. We're going to actually calculate that out. So if you're thinking tangent, it's 1/2 over root 3 over 2. That's a compound fraction. This means division. So we can rewrite it as 1/2 divided by root 3 over 2.
Which means we can flip it, cross multiply.
When we don't divide, we multiply by the reciprocal. So that's equal to 1/2 times 2 over root 3. So we flip that back, which these cancel. You get 1 over root 3. You can't leave a radical in the denominator, so we rationalize by multiplying by root 3 over root 3, which is root 3 over 3. So that means this is root 3 over 3. Now, that's an awful lot. That's an awful lot of math to figure that out. Okay? Yeah.
How'd you get a 1 after you did flip the fraction 1 times 2 over 3 over root 3, and then you got
Right here?
Yeah.
These cancel. Cross cancel.
Oh, okay.
Yep. Okay? Hey guys, the expectation is you knew how to do these ones. Or maybe not so much this one, but you could get there. Now, when I'm looking at cosecant, cosecant is the reciprocal of what? It's a reciprocal of sine. You would think it would go with cosine because they both start with c, but it doesn't. It's the opposite of that. So it's a reciprocal of sine. So the reciprocal of 1/2 is 2. The reciprocal of, for secant, of cosine is 2 over root 3. Can't have that. 2 over root 3.
It's root 3.
Okay? Can't have that. We've got to multiply it by root 3 over root 3. 2 root 3 over 3.
Whoa, no, I lied. Yeah, wait, that's the value. Oh, and then we have to put cosecant.
Reciprocal of tangent is 3 over root 3, right?
Which is
So 3 over root 3. So we multiply by root 3 over root 3 again. That's special number 1, which gives us 3 root 3 over 3, which is root 3.
wait,
And the degree measure of pi over 6 is 30.
degrees.
That's what you're doing in this table for every one. Now, many of you are going to get really fast at this. Some of you are going to be kind of slower at it, but the point is, that's what you're doing right now. You can work with your groupies, do your best. Let's take a look at the final product here. This is my page. I've highlighted the 45s for you. Now, hopefully, I know that some of you found the pattern because you finished it up pretty quick. But when you're looking through this, well, why don't you guys, what are the patterns? Like, how far do I legitimately need to calculate down before I can just start filling things in by flipping signs and doing stuff like that? Elizabeth?
The first 4, 5.
So down to here?
Yeah.
Good. Down to 90. All right? Remember, 2 pi over 3 is just same as which one? Or similar to which one? It's similar to 60. Okay? It's also similar to pi over 3, right? I mean, you start seeing like this right here, this line, 1/2 root 3 over 2, root 3 over 3, 2. Okay? That repeats itself right here. Just parts of it. Oops. Hold on. I missed that. Right here. Okay? So these two repeat. There are different pieces that repeat in different spots when you go from pi over 6 to pi over 3, the secant and cosecant. We start seeing some patterns here. So our 1/2, where else is sine 1/2? Well, it's right here. Okay? All right, who filled this in really fast? So Riley, what'd you use? So like, how'd you fill it in so quickly?
Well, I just like looked back at ones I already did and kind of like it's kind of.
Did you go down to 90? Did you fill in down to here first, or did you just kind of?
I did the first like 1, 2, 3, 4, and then I used the ones that come down.
Okay, so you went down to here and you used those.
Yeah.
All right. So 60 went with 120.
Yeah, all the multiples of 60.
Good. 60, 120, 180.
And then 30 is all the multiples of 30, taking out the 60s.
Okay, so 30.
And 90s.
Okay, so it's every other 30, other than the 90s. So we have 30. We skip 60, 90. We go to 120.
We go to
150. Yeah, we skip 120 because it's a multiple of 60. Okay.
180.
All right. So there are different patterns you can use. I know that some of you use the ones where some of you may have been going through and saying, well, I know that this is this sign and this, like when I'm dealing with 30 and 60, this sign goes here and the cosine goes there. They just switch spots. Notice you get some undefineds here. That's going to be one of your questions on your homework tonight on the page 608, 609, that 1 through 6 there. One of the questions is going to talk about undefineds and why you have them. Think about tangent meaning sine over cosine, and if I have if I have, in this case, 1 over 0, sine over cosine, that puts a 0 in the denominator. That's undefined. Okay. In a similar situation, when I have this guy here, tangent, well, to write tangent as a fraction, I put a 1 under it, so it's 0 over 1. Well, when I flip that, I get 1 over 0 for cotangent. That's undefined. Okay? Any questions on this? Make sure your table's accurate. We're going to use that tomorrow for graphing. I'll leave it up there for you.